Welcome to the Deep Dive. Today we're zeroing in on something really fundamental to our health, but it often gets this kind of simplistic label, cortisol.
The stress hormone.
Exactly, it's a stress hormone. But we want to go, way deeper than just stress
Yeah.
today.
Mm.
We're looking at how when cortisol is out of whack, maybe too high, maybe too low, it can actually be a surprisingly big root cause for a whole range of health issues.
Yeah. It's not just about feeling stressed. It's about the underlying biology, the machinery sort of going off key.
Right. And you've mentioned before, cortisol isn't just about stress response, is it?
No, not at all. It's a huge player in our metabolism, how we use energy, process nutrients, and even how our immune system functions day to day. It's got its fingers in a lot of pies, so to speak.
Okay. So maybe think of it like a guitar string.
Good analogy.
If you tighten it way too much, that could be like chronic high cortisol, or if it's too loose, like low cortisol.
It's just wrong. It sounds, well, discordant.
Uh,
Exactly. Discordant. And our hormones, they need that balance, that, sweet spot for everything in our bodies to work together harmoniously.
mhm.
And the big idea we're exploring today is that this long-term cortisol imbalance, it's not just feeling bad, it can genuinely create a biological environment where we're just more vulnerable.
More susceptible.
Yeah, susceptible to all sorts of problems,
Yeah.
from those, nagging little infections you can't seem to shake,
Right.
to maybe more serious chronic conditions down the road. The key thing, really, is that high cortisol can act like this systemic saboteur. It
Right.
weakens our foundations.
And that makes us vulnerable in different ways, doesn't it? Depending on our own individual makeup, our genetics, our lifestyle.
Precisely. Which is why understanding it is so important. It's all interconnected, isn't it?
Oh, absolutely. We tend to look at symptoms or specific diseases kind of in isolation, right?
Yeah.
But cortisol gives us this broader lens. Suddenly, our lifestyle choices, our mental state, even the food we eat.
Things we might not think are directly related. Exactly. They all exert this powerful influence on our cortisol balance. It's fascinating, really.
It really is. And it makes you wonder, too, about things like, why do older adults sometimes seem more prone to getting sick?
That's a really interesting question.
Could it be that decades of maybe subtle, ongoing disruptions to their cortisol rhythms contribute to that increased vulnerability?
It's certainly a plausible factor to consider. Yeah. The cumulative effect over time.
But the good news here, the empowering part of this deep dive, is that understanding this gives us, actionable knowledge.
Right. It's not just theoretical.
No, by getting this connection, we can actually do things, be proactive about bringing back that hormonal harmony.
Yeah, that's our mission today, really, to properly grasp this link, this really pivotal link between cortisol imbalance and, disease.
And explore how maybe aligning ourselves better with our natural rhythms, aiming for healthy cortisol levels, how that could be a powerful path to better health.
And vitality. Yeah, it's foundational.
Okay, so foundations. Let's start right at the beginning. Where does cortisol even come from? How does the body make it?
Okay, so it all starts with a molecule most people have heard of, cholesterol.
Cholesterol.
Yeah.
Okay, the stuff we usually hear about in terms of heart health.
That's the one.
Hmm.
But it's also essential. Think of it as the initial raw material. Our body takes cholesterol and uses it to build another molecule called pregnenolone.
Pregnenolone. Okay, I've heard that mentioned in hormone discussions. What does it do?
Well, pregnenolone is often called the mother hormone because it acts as this key precursor, this sort of stepping stone.
Right.
From pregnenolone, the body can then make several other really important hormones, specifically progesterone and cortisol.
Ah, so they both come from the same starting point, pregnenolone.
Exactly. They share that common origin.
Okay, that makes sense.
Yeah.
Now let's get into the really interesting part. What happens when cortisol levels go up? And how does that mess with these other related hormones, like progesterone and estrogen?
Yeah, this is where the domino effect really starts. When your body senses a need for more cortisol, maybe because you're under stress or there's inflammation,
Right.
it prioritizes making cortisol. The available pregnenolone gets shunted preferentially towards that cortisol production pathway.
So it's like the body says, emergency, we need cortisol now.
Pretty much. And the consequence is there's less pregnenolone left over to be converted into progesterone.
Okay, so progesterone production takes a hit.
It can, yeah,
Yeah.
leading to lower progesterone levels. It's often described as the pregnenolone steal.
Pregnenolone steal. Okay, so high cortisol
Mm.
directly lowers progesterone.
Mm.
But but I feel like there's more to it.
There is, yeah. There's another layer. It's not just about diverting the precursors. Some of the progesterone that is actually made
Uh,
can also be converted into cortisol by the body if the demand remains high.
wow. Okay, so the body can dip into its progesterone supply too.
It can, essentially raiding the progesterone reserves to keep up cortisol production. So it's like a double hit for progesterone levels when cortisol is chronically high.
A double whammy.
Yeah.
And we know progesterone is super important, especially for balancing out estrogen, right?
Absolutely. Progesterone acts as a natural counterbalance to estrogen. So when progesterone levels are low,
But that check on estrogen is gone or weakened.
exactly, the balance tips and estrogen levels can start to rise relative to progesterone. This is often part of what's called estrogen dominance.
Okay. And does this rising estrogen then affect testosterone too?
It can, yes, there's a connection there. As estrogen levels go up, the body might try to compensate or rebalance by converting some testosterone into estrogen
How to do that?
through an enzyme called aromatase. So that's one way testosterone levels can drop.
Right.
But also, high cortisol itself directly has a suppressive effect on testosterone production in the testes and ovaries.
So multiple pathways leading to lower testosterone when cortisol is high.
Yes, it's a cascade, really. A whole series of hormonal shifts kicked off by that initial sustained increase in cortisol demand.
A hormonal storm, basically. Okay, so let's back up slightly. What actually causes cortisol to go up like that in the first place? The sources talk about direct and indirect causes.
Yeah, that's a useful distinction. Direct causes are things that pretty immediately signal the adrenal glands, those little glands sitting on top of your kidneys, to pump out more cortisol.
Like what?
Well, caffeine is a big one. Coffee, black tea, cola, those energy drinks.
Uh-oh, my morning coffee.
Yeah, they can directly stimulate the adrenal glands. Sometimes this involves the pituitary gland releasing ACTH, adrenocorticotropic hormone.
ACTH, that's the messenger hormone.
Exactly. ACTH tells the adrenals, hey, make more cortisol. Caffeine can trigger that messenger.
Okay, caffeine. Noted. What else acts directly?
Inflammation is another major one. Any kind of significant inflammation in the body.
From what? An infection.
Yeah. Could be an infection like the flu or strep throat, or a physical injury, a wound. Even really intense, strenuous exercise can cause a temporary inflammatory response.
And food. You mentioned food combinations earlier.
Right. Sometimes certain food combinations or sensitivities can trigger an inflammatory response in the gut, and the body reads that inflammation as a stressor.
Interesting. So inflammation signals stress to the body, triggering cortisol.
Essentially, yes. Cortisol has anti-inflammatory properties, so it's released partly to try and manage that inflammation. But chronically, that's not good.
Okay, those are the direct hits. What about the indirect causes? This involves that whole HPA axis, right? Hypothalamus, pituitary, adrenal.
Exactly, the HPA axis. This is more about a chain reaction of signals, usually starting in the brain.
Triggered by?
Stress. But not just physical stress. Psychological stress is a huge one here.
Like work deadlines, relationship issues, financial worries.
All of that, chronic worry, feeling constantly overwhelmed, that feeling of just having too much on your plate. The sources mention never stop thinking.
That constant mental chatter.
Yeah.
Yeah, I know that feeling.
Right, so these kinds of stressors activate the hypothalamus in your brain.
Okay, step one. Hypothalamus gets alerted. Then what?
The hypothalamus sends a signal, a hormone called CRH, down to the pituitary gland.
Step two. Pituitary gets the message.
Then the pituitary releases that messenger we mentioned, ACTH, into the bloodstream.
And ACTH travels to the
Adrenal glands, telling them to produce and release cortisol. So the trigger wasn't directly poking the adrenals, but it set off this whole communication cascade that results in more cortisol.
Got it. So stress, mental, emotional, physical, kicks off this HPA axis chain reaction.
Precisely.
Okay, so we understand the triggers now, direct and indirect. Let's get to the really crucial bit, the consequences. What happens when cortisol stays high, chronically? The sources talk about this creating a biological ground state for disease. What does that actually mean?
It's a powerful concept. Basically, it means that having persistently high cortisol levels changes the internal environment of your body. It creates conditions that make it, well, easier for various dysfunctions and diseases to develop.
Like preparing the soil for weeds to grow, maybe.
That's a great way to put it, yeah. Cortisol isn't necessarily the only seed, but it definitely makes the soil much more fertile for those weeds, those diseases, to take root and thrive. It weakens your overall resilience.
Okay, let's break down some specific consequences. The immune system seems like a major casualty.
It really is. Chronically high cortisol is known to suppress immune function in several key ways.
How so?
Well, for starters, it reduces the activity of T cells. These are critical immune cells that fight off infections and are also involved in identifying and destroying cancerous cells.
Okay, so T cell activity goes down.
What else? It also dampens the production of antibodies, which are proteins your immune system makes to recognize and neutralize specific threats like bacteria and viruses.
Hmm.
So your ability to build immunity is impaired.
Right.
And importantly, it seems to impair the body's general surveillance system, its ability to spot and eliminate abnormal cells before they potentially turn into tumors.
So weakened defenses across the board. And this shows up how?
It can manifest as just being more vulnerable, getting sick more often with viruses like the flu, bacterial infections like strep throat, or even pneumonia, fungal infections.
Things you might normally fight off easier.
Exactly. Or even more serious infections if the suppression is significant.
That's a concerning list. Okay, what's another major area affected? The sources mention increased cellular metabolism. Sounds almost good, like burning more energy.
You'd think so, but it's not quite like that in this context. Elevated cortisol does speed up certain metabolic processes at the cellular level, but the downside over the long term is a big increase in the production of free radicals.
Free radicals.
Mm-hmm.
Reactive oxygen species, ROS. The things that cause oxidative stress.
Precisely. These are unstable molecules that can damage important structures like our DNA and the mitochondria, the energy factories within our cells.
Okay, and that damage leads to...
Over time, it contributes to tissue breakdown degeneration. It's a fundamental process linked to aging and the development of many chronic diseases.
Including cancer.
Yes, including cancer. This oxidative stress and DNA damage can contribute to mutations. Plus, cortisol can promote something called angiogenesis.
Angiogenesis, building new blood vessels.
Right. Which sounds helpful, but unfortunately, tumors can hijack this process to build their own blood supply, allowing them to grow and spread.
Wow, so high cortisol is lowering defenses and potentially helping fuel tumor growth. That's disturbing.
It highlights how profound the effects can be.
What about hormonal balance? We touched on progesterone and testosterone dropping earlier. Does it get worse?
It does. Chronically high cortisol really throws that delicate hormonal balance further out of whack. We mentioned progesterone and testosterone.
Yeah.
On top of that, it can interfere with the body's ability to properly clear or detoxify estrogen.
So estrogen can build up.
Potentially, yes, contributing to that state of estrogen dominance we talked about, which brings its own set of health issues.
Right.
It can also elevate levels of other hormones like prolactin and DHT, dihydrotestosterone, which can cause further imbalances affecting everything from mood to hair growth to prostate health in men.
It really sounds like cortisol is just throwing the whole hormonal orchestra completely out of tune.
That's a very apt way to describe it. It disrupts the harmony.
Okay, another consequence listed is modification of gene expression. That sounds incredibly fundamental.
It is. We're talking about epigenetics here.
Epigenetics.
Yeah,
Like changes in how our genes are read, not changes to the genes themselves.
exactly. Think of them like little sticky notes or volume dials on our genes. Cortisol can influence these epigenetic marks, things like DNA methylation or histone modification.
And how does that play out with chronic high cortisol?
Well, unfortunately, it can lead to negative changes. It might silence tumor suppressor genes, the genes whose job is to prevent cancer.
Oh, wow.
Or, conversely, it might activate oncogenes, genes that can actually promote cancer development when switched on.
So it's potentially reprogramming us at a genetic level towards disease.
In a sense, yes, by changing how our genetic blueprint is being used or expressed. It's a very concerning long-term effect.
Definitely. And the last big one mentioned here is impaired restorative sleep. This feels like a vicious cycle.
It absolutely is. High cortisol levels, especially at night when they should be low, make it hard to fall asleep and stay asleep.
Right, because cortisol's alerting, it wakes you up.
Exactly. But then poor sleep itself signals stress to the body, which can further elevate cortisol levels.
Oh, catch-22.
Totally. And when you're not getting that deep restorative sleep, your body produces less melatonin.
Melatonin.
No.
Sleep hormone, but it's also an antioxidant, right?
A very powerful one, yes. It helps protect our cells from damage. So less melatonin means less antioxidant protection overnight. Plus, lack of good sleep leads to neural fatigue. Your brain just doesn't function as well, and it promotes chronic systemic inflammation.
Which just feeds back into all the other problems we've discussed.
Precisely. It worsens the whole situation.
Okay, so this cascade is huge. Immune suppression, cellular damage, hormonal chaos, gene expression changes, poor sleep.
Hmm.
It's systemic.
Deeply systemic.
Now let's layer something else on top. Insulin. The sources really emphasize the interplay between high cortisol and high insulin. How do these two work together, or rather, against us?
This is a really, really critical connection. They often go hand in hand. High cortisol frequently leads to higher blood sugar levels, hyperglycemia.
Why is that?
Cortisol tells the liver to release stored glucose and make new glucose, raising blood sugar to provide energy for that perceived fight or flight situation.
Okay.
But if this is chronic and you're not actually fighting or fleeing, your pancreas has to pump out more insulin to try and get that excess sugar out of the blood and into the cells.
So high cortisol leads to high blood sugar, which leads to high insulin.
Often, yes. And this combination of chronically high cortisol and high insulin has massive, far-reaching effects throughout the body. It's a really damaging duo.
All right, let's walk through the body, system by system. Starting with the endocrine system itself, hormones and glands. What's the impact there?
The big issue is insulin resistance. When cells are constantly bombarded with both cortisol and insulin, they start to become less responsive, less sensitive to insulin signal.
They sort of tune it out.
Kind of like that, yeah, which
It-
means the pancreas has to work even harder, pumping out even more insulin to get the job done.
That sounds exhausting for the pancreas.
It is. Over time, this can lead to beta cell exhaustion. Those are the cells in the pancreas that make insulin. They can get worn out, and insulin production can eventually decline. This is a key pathway towards type 2 diabetes.
Okay, so insulin resistance and potential diabetes.
Sure.
What about the cardiovascular system, heart and blood vessels?
This combo is really bad news for heart health. For one, it contributes to hypertension, high blood pressure,
Wow.
partly because insulin tells the kidneys to hang on to more sodium and water, which increases blood volume and pressure. Cortisol also constricts blood vessels. Plus, this environment promotes atherosclerosis, the hardening and narrowing of arteries. It increases inflammation in the vessel walls, damages LDL cholesterol, making it more likely to form plaque, and harms the delicate inner lining of the arteries, the endothelium.
So plaque buildup, stiff arteries.
Yeah. And we often see dyslipidemia too, unhealthy blood fat levels. Typically low HDL, the good cholesterol, and high triglycerides, all major risk factors for heart attacks and strokes.
It really is a double whammy for the cardiovascular system. Okay, moving on. Musculoskeletal muscles and bones.
Cortisol, as we said, is catabolic. It breaks tissue down. High cortisol actively promotes muscle wasting, breaking down muscle protein to create glucose.
Which just makes the blood sugar and insulin situation worse.
Exactly, it's counterproductive. And for bones, both high cortisol and the associated insulin resistance can interfere with bone building. They reduce the activity of osteoblasts, the cells that build new bone, and increase the activity of osteoclasts, the cells that break down old bone. The net effect is weakened bones, increasing the risk of osteopenia and osteoporosis.
Losing muscle and bone density.
Yeah,
Not good.
sure.
What about adipose tissue, our fat stores? Where does the fat go?
This combination particularly encourages fat deposition right around the abdomen central obesity, or that visceral belly fat.
The dangerous kind of fat.
Yes, because visceral fat isn't just passive storage, it's metabolically active. It churns out inflammatory chemicals called cytokines,
Right.
which fuels that chronic low-grade inflammation throughout the body and actually worsens insulin resistance. It's another vicious cycle.
Okay. And the liver. It processes everything. How does it cope?
Not well. High insulin signals the liver to make more fat, a process called de novo lipogenesis. This excess fat gets stored in the liver itself.
Leading to fatty liver disease.
Exactly. Non-alcoholic fatty liver disease, or NAFLD. And the disrupted glucose metabolism also impairs the liver's ability to store glucose properly as glycogen, which again makes blood sugar control harder.
Man, it feels like these two hormones, cortisol and insulin, when they're chronically high together, just create havoc everywhere. What about the kidneys?
They take a hit too. The chronic high blood sugar and high pressure inside the tiny filtering units of the kidneys, the glomeruli, can cause damage over time. This is known as diabetic nephropathy, a major cause of kidney failure.
And the sodium retention we mentioned earlier.
Yeah, driven by insulin that contributes to, leading to fluid retention, edema or swelling, and worsening high blood pressure, which further strains the kidneys.
Okay. Nervous system. Brain and nerves. How are they affected?
Well, there's growing evidence linking insulin resistance to problems with brain function. It seems to impair how well brain cells can take up and use glucose, their primary fuel.
which could lead to cognitive issues.
Yes, potentially contributing to cognitive impairment, brain fog, and even increasing the risk for conditions like Alzheimer's disease, which some researchers are now calling type 3 diabetes.
Wow. Type 3 diabetes.
And beyond the brain, the prolonged high blood sugar can directly damage peripheral nerves throughout the body, leading to neuropathy, numbness, tingling, pain, often in the hands and feet.
It's just so widespread. What about the immune system again? We know cortisol suppresses it directly. Does the high insulin add to the problem?
It does, mainly through that chronic inflammation connection. While cortisol directly suppresses certain immune cells, the low-grade inflammatory state driven by insulin resistance can actually dysregulate the immune system in other ways.
So it's suppression and dysregulation.
Kind of. The overall picture is often weakened defenses against acute infections, but also this simmering background inflammation that might paradoxically contribute to autoimmune conditions or make them worse. It's complex.
Okay. Even our digestion gets involved, right?
Absolutely. This hormonal imbalance can mess with the signals that control hunger and fullness hormones like ghrelin and leptin.
Leading to increased appetite.
Often, yes. Increased appetite, cravings, particularly for sugary or high-carb foods, which obviously doesn't help the situation, it can contribute to overeating and weight gain.
And the gut itself. The microbiome.
That chronic inflammation we keep mentioning can definitely alter the balance of bacteria in your gut microbiome. This can contribute to increased intestinal permeability, sometimes called leaky gut, where the gut lining becomes less effective as a barrier.
Letting things into the bloodstream that shouldn't be there.
Exactly. Which can then trigger more systemic inflammation. It's another feedback loop.
Okay, one more system.
Yeah.
Reproductive. How does the cortisol-insulin duo impact that?
Significantly. In women, insulin resistance is a major factor in conditions like polycystic ovary syndrome, PCOS, which involves hormonal imbalances and often fertility issues.
Right.
In men, high cortisol and insulin resistance are linked to lower testosterone levels, affecting energy, mood, libido, and muscle mass.
And fertility in general.
Yes, for both genders. High cortisol can suppress the brain's release of GnRH, gonadotropin-releasing
The
hormone.
master regulator for reproductive hormones.
That's the one. Suppressing GnRH disrupts the whole downstream cascade of hormones needed for normal ovulation in women and sperm production in men, potentially impairing fertility. And there's also a link mentioned to prostate enlargement in men.
Good grief. It's genuinely a systemic breakdown when these two are chronically elevated. It affects literally every part of the body.
It really underscores how interconnected everything is. You can't isolate one system.
Which brings us perfectly to this core principle the sources highlight. Common root, divergent outcomes. Can you unpack that for us? What does that mean in practice?
Yeah, it's a crucial concept. It means that while chronically elevated cortisol acts as this significant underlying factor, a common root for many different chronic diseases,
Right.
the specific disease that actually shows up in any given person isn't just determined by the high cortisol.
Okay, so cortisol loads the gun, maybe.
That's one way to think about it, yeah. It creates the fertile ground, the vulnerability, but what specific disease manifests depends on a whole host of other factors unique to that individual.
Factors like what?
Things like your genetic predispositions. You might be wired to be more susceptible to, say, cardiovascular issues or autoimmune problems. Your nutritional status plays a huge role. Deficiencies can worsen things.
Makes sense.
How you regulate your emotions, your history with stress or trauma that deeply influences your HPA axis function. Your sleep quality and your circadian rhythms are vital. And then there are environmental exposures, toxins, chronic infections, things like that.
So it's the cortisol plus these individual factors that determine the outcome.
Exactly. High cortisol creates the vulnerability, but these other factors steer how that vulnerability expresses itself.
The sources give some examples of how this might play out differently in different people.
They do. For instance, in someone with, say, a genetic susceptibility and hormonal sensitivities already, that chronic high cortisol might be the tipping point for a tumor developing in hormone-sensitive tissue, like breast or prostate.
Yep.
In another person, maybe someone with poor circulation or diabetes already, the main manifestation might be really slow healing wounds because cortisol impairs tissue repair and immune function.
Right.
Or think about someone who had maybe Epstein-Barr virus years ago. That virus can lie dormant. But under chronic stress, the cortisol-induced immune suppression might allow that latent infection to reactivate and cause symptoms again.
Ah, okay, I see.
And in yet another person, the combination of high cortisol, maybe some genetic factors, and poor sleep might manifest primarily as progressive neurological issues, brain fog, cognitive decline, maybe contributing to neurodegenerative conditions over time, or prostate issues, or just that unrelenting fatigue.
So same root, high cortisol, but very different branches depending on the individual landscape.
Precisely. Common root, divergent outcomes.
And the source is going to summarize the specific impacts we've talked through. Narrowing arteries, high blood pressure, sodium retention, kidney damage.
Yeah, the reduced cellular metabolism, the lower antioxidant capacity, less sugar getting to the brain, nerve damage.
Digestive issues, DNA damage, mitochondrial dysfunction, silencing those protective tumor suppressor genes.
And all the reproductive problems like infertility and PCOS. It really paints a picture of how one underlying imbalance can ripple outwards and contribute to so many seemingly unrelated health problems.
It really does. It's incredibly comprehensive when you lay it all out.
It highlights why just chasing symptoms often isn't enough. We need to look at these deeper underlying drivers like cortisol imbalance.
Okay, so let's try and bring this all together. The big takeaway here, it seems, isn't just that cortisol is the stress hormone making us feel frazzled.
No, it's much bigger than that.
It's that chronically high cortisol fundamentally alters our internal biology. It creates, as you said, that fertile ground, making us much more susceptible to a whole spectrum of chronic diseases.
Exactly. It weakens the foundations. It sets the stage.
And this is the hopeful part, we can influence this.
Yes, absolutely. That's the empowering message. Addressing cortisol levels through lifestyle is key.
Things like,
Well, genuine stress reduction techniques, finding what works for you, whether it's mindfulness, meditation, time in nature. Prioritizing restorative sleep is non-negotiable.
right,
Learning to process emotions in healthy ways instead of letting them fester. Supporting your metabolism with whole foods, balancing blood sugar. These aren't just nice to haves.
they're fundamental for prevention and healing.
They're absolutely crucial, yes, for both preventing these conditions from developing in the first place and for supporting the body's innate ability to heal if things have already started to go off track.
So for you listening, this isn't just, interesting science. It's really an invitation.
An invitation to reflect.
Yeah, take an honest look at your own lifestyle, your stress levels, your sleep, your diet, how you handle emotions. How might those factors be influencing your cortisol balance right now?
And how might that be impacting your health trajectory long term?
Exactly. Hopefully this deep dive has maybe sparked some ideas, some areas you might want to explore further for yourself. Maybe specific strategies for managing stress better, or improving sleep, or eating in a way that supports hormonal balance.
Because understanding this connection is the first step towards potentially bringing things back into a healthier harmony.
Definitely food for thought. Something to consider as you navigate your own health journey.